The magnitude of thermal energy, Q, when a student produces 12.5 grams of water is 174 kilojoules. The reaction that was performed is shown below. The combustion of ethane is exothermic. Calculate the experimental delta H. So since we know that combustion is exothermic, we know that the delta H value, even though it only gives us the magnitude, so the absolute value, is going to be negative 174 kilojoules released when 12.5 grams of water is produced. So since we know that we get a negative 174 kilojoules per 12.5 grams of water, we want to know how many kilojoules, so how many kilojoules do we get for the entire reaction, so for 6 moles of H2O. How many kilojoules do we get per 6 moles of H2O? This is what we're trying to get to here. So the first step is to figure out the number of kilojoules per 1 mole of water. And then once we have the number of kilojoules per 1 mole of water, then we can convert this to the number of kilojoules per 6 moles of H2O. So there's kind of our process here. We start out with the number of kilojoules for a certain mass. We want to know the number of kilojoules per 1 mole of water, so then we can get to the number of kilojoules for the whole reaction that produces 6 moles of water. So to start out, let's convert that 12.5 grams of water into moles, so then we can figure out the kilojoules per mole. So 12.5 grams of H2O, and we're going from grams to moles. 1 mole of water is about 18 grams. So if we, in our calculator, do 12.5 divided by 18, this is about 0.6944 repeating decimal for moles of H2O. So now we want to know the number of kilojoules per 1 mole, so we kind of need to simplify. So we have negative 174 kilojoules per this number of moles right here that we just found, this number right here. So we need to kind of simplify it down, 69444, and I'm actually going to use the values in my calculator. That's the number of kilojoules per that many moles of H2O. So we'll just simplify this by dividing. So negative 174 divided by that number of moles, so that gives us negative 250.560 kilojoules per 1 mole, per mole. So we're just simplifying the numbers here. And I should put per mole of H2O. Okay, so we figured out the number of kilojoules per 1 mole of H2O. We did that part. Now we just need to figure out the number of kilojoules per 6 moles of H2O. So to do that, all we really need to do is cancel out this moles of H2O part on bottom. And so there's lots of ways to do this. This is the number of kilojoules per mole of H2O. So you could start and say, okay, if that's the number of kilojoules per 1 mole, then I want to know the number of kilojoules per, and this is not a good color for this, let me try a different color. I want to know the number of kilojoules per 6 moles of H2O. And so I'll use this as a conversion factor. So moles of H2O, for every 1 mole of H2O, I have negative 250.56 kilojoules. And so that's one way to set it up. So your moles of H2O just cancel out, and you're left with simply kilojoules. We could also do a similar process without rearranging. So we could just make moles cancel, put moles of H2O on top, 6 moles of H2O, and we know by multiplying by just that part, 6 moles of H2O over 1, that will make our moles of H2O cancel as well and leave us with kilojoules. This is essentially the same thing. It's just the order of the conversion factors that you're listing in. Okay, and so when we multiply this out, 6 times 250.56 in both cases, either way you set it up, it's going to be the same answer. When I multiply this out, I get 1503.36. Now this is just the number of kilojoules. Now of course we do need to round to sig figs, and both of our given values in the problem have 3 significant figures. So I'm also going to round our answer to 3. So 150, and we can't actually get this to 3 significant figures without putting it in scientific notation. So I'm going to move my decimal point and put 1.50 times 10 to the 3rd kilojoules as my answer here. I will also put my answer up here. 1503.36 to 3 sig figs is 1.50 times 10 to the 3rd kilojoules. And so that is the delta H for the entire reaction. The entire production process for 6 moles of water is 1.50 times 10 to the 3rd kilojoules.